Hello everyone. In this video, we are going to cover absolute value function. I forgot the value. Okay, so by the definition, the absolute value function is going to define as a piecewise function, which is if x is positive, the output is going to be a positive number. If the input is a negative number, the output is going to be a positive number. So that means you want to take the negative again. So that would be the definition. So how do you interpret this one? So if x equals 1, the output will be 1, right? So if the input is -1, the output is going to be the negative of -1, which gives you +1, which is our definition of absolute value function. All the negative will become positive. 0 will remain the same. So, first of all, how do you understand a absolute value function? So remember, absolute value function is trying to describe the distance from a certain number. For example, I want you to describe all the values x within a distance of 4 from the number 5. So that means on the number 9, this is the number 5. So here is 9, here is 1. So these numbers are all x, because within this range, the distance from x to 5 is going to be within the distance of 4. So in an absolute value function, this can be written as when x minus 5, the absolute value should be less than or equal to 4. That means within this distance, 4. Okay, another example can be this one. So in 2010, a poll reported that 78% of Americans believe that people who are gay should be able to serve in the US military. With a reported margin of error of 3%, the margin of error tells us how far off the actual value could be from the survey value. So express the set of possible value using the absolute value. So that means since we want the size of the differences between the actual percentage P and the reported percentage to be less than 3%, so I can return as the actual percentage should be P minus 78% should be within 3%. So here is the expression. So another thing for the absolute value function is we know the absolute value function is going to look like the graph of a v, right? Fx equals to absolute value of x. So what if the opposite? I'm giving you an absolute value function in here, and the vertex would be 3 and -2. Oh, this is maybe not the best graph. And here is going to be 4, 0. And here is 2, 0. Here should be 0 and 4. I want you to find the function. Well, think about it. We already learned the transformation of function in chapter 1, and we know that, hey, the function is going to come from y equals to absolute value of x. Let's see what change they have been happened in here. First of all, we know that, hey, the vertex shift to the left shift to the right 3 units, and shift down -2 units. So that means at least the basic one we have should be x minus 3. That means shift to the right, and the -2 means shift down. And now we need to take a look at the vertical stretch or the horizontal stretch. Okay, so look at this graph. How do you determine if this is a vertical stretch or a vertical or horizontal stretch? Well, we can take a look at the slope, because originally the slope, the original function is fx equals to absolute value of x. That means on each side the slope m should equal to 1. So now let's take a look at this slope. So from these 2 points, let's pick random 2 points, we can have the slope equals to 4 minus 2 over 0 minus 2, which is -2. So that means the slope is going to be -2. But however, this is an absolute value function. That means on the other side. Or we can pick the slope on the right side of the function, which is, I'm using a green pen to represent that. I have what? 0 minus -2 or over 4 minus 3, give me the slope is equals to a +2. So why happened with that? Because when it comes to absolute value function, everything is going to flip. So we know that the slope is going to change from 1 to 2, right? All the negative sign we can ignore here since this is a absolute value function. So that means the graph is going to stretch vertically 2 units. So that's why here is 2. So here we go. We got this function by the transformation of function. Okay, so the next part of how do we solve absolute value of function. So think about that. If I tell you the absolute value of a is equal to 4, so a, they could have 2 possibilities, right? Either a equals to +4 or a equals to -4. Correct? When we would move the absolute value sign. So that means this is similar to every polynomial. If I'm giving you the function 4x plus 1 minus 7 equals to 0, I want you to solve for x. Well, I add 7 on both sides, then I will have 4x plus 1 equals to 7. All right, now let's take a look. So when I try to remove the absolute value sign, what happened? When you remove it, that means inside the absolute value 4x plus 1, this polynomial can equal to +7 or -7. So that means we might have 2 results. We might end up to have 2 results. 4x plus 1 equals to +7, or 4x plus 1 equals to -7. And then we solve these 2 equations. I will have 4x equals to 6, x equals to 6/4. When we simplify, we will got 3/2. For the other one, I have 4x equals to -1 on both sides. I have -8 divided by 4, so x equals to -2. So you will end up to have 2 different answers. Both answers, if you substitute into the function to check, you will notice that, hey, they both equals to 7. Okay, so something like, hey, I want you to find the x-intercept and y-intercept for the function fx equals to -x plus 2 plus 3. Okay, in here, y-intercept is easier, so let's try to find the vertical intercept first. So y-intercept is when x equals to 0. Okay, So when x equals to 0, we substitute into the function. I have f of 0 equals to negative 0 plus 2 plus 3, which is negative absolute value of 2 plus 3, which is negative 2 plus 3, gives you 1. So that means the y-intercept is 0, 1. Okay, now x-intercept, the horizontal intercept. So horizontal intercept is where when y equals to 0. So now I'm going to set the equation equals to 0. Okay, now let's try to solve for x. We subtract 3 on both sides. I have x plus 2 equals to negative 3, negative x plus 2. And now, before you remove the absolute value sign, the first thing we need to do is divide it by negative 1 on both sides to get rid of the negative sign. So I have x plus 2 absolute value equals to positive 3. Now we can remove the absolute value sign. I have either x plus 2 equals to positive 3 or x plus 2 equals to negative 3. Now continue to do that. I subtract 2 on both sides. I would got x equals to 1 or x plus 2, which is I subtract 2 on both sides, gives you x equals to negative 5, which means our x-intercept, we will have two x-intercept. One is 1, 0. The other one is negative 5, 0. So some other possible example would be, hey, if I'm giving you a function, fx equals to negative 1/2 4x minus 5 plus 3, and I want you to determine for what x value the function values are negative. Well, we can try to draw the function since you already learned the transformation. So I'm going to skip in the step here. So the function should look like something like that. After you draw the graph, it's really clear. So they ask you, hey, when the function are going to be negative. So that means you're looking for these two parts, because in these two parts, the function are going to be negative, right? So this is a way to help you to visualize the function. So to solve it step by step should be, I want negative 1/2 x, 4x minus 5 plus 3. I want them to be less than 0, because negative means the function value is less than 0. Now let's solve the inequality. So 1/2 4x plus minus 5 less than negative 3. And then I multiply negative 2 on both sides. When you multiply a negative number, what happens? You need to flip the inequality sign. So I will have absolute value of 4x minus 5 greater than 6. Okay, so when the absolute value is greater than, that means the value is either going to be 4x minus 5 greater than 6 or 4x minus 5 less than negative 6. Okay, so let's continue to do these two different calculations. I add 5 on both sides. So I have 4x greater than 11. So that means x has to be greater than 11 over 4. On the other side, at 5 on both sides, I have a 4x less than negative 1 divided by 4 on both sides. I got x less than 1/4. So on the graph, here should be negative 1/4. Here should be 11/4. But what if I have a calculation like solve negative 2k minus 4 less than or equals to negative 6. Again, solve for k. We divide it by negative 2 on both sides. In here, when you divide something in negative, you need to flip the sign. So that means I have a k minus 4 less than or equals to 3. Oh, and then you need to flip the sign, which is greater than or equal to 3. When it's greater than, that means when you remove in the inequality, you will have the result either k minus 4 is greater than 3 or k minus 4 is less than or equals to negative 3. And now you do the calculation, you will have k greater than 7 or k less than or equals to 1. On the number 9, this should look like greater than 7 is on this side, and then less than 1 should be on this side. Okay. What about if the inequality is less than, such as I want you to solve, hey, 2k plus 4 less than or equals to 5. So what happens if the inequality is less than or equal to instead of greater than? So that means the result should be either 2k plus 4 is less than 5 or greater than or equals to negative 5. So if the inequality is less than, the result should be in between. When you're solving these, it will be the same. You need to add 4, subtract 4, sorry. You need to subtract 4 on both sides to get rid of the 4. So I will have negative 9 less than or equals to 2k less than or equals to 1, and then divided 2 on every term, divided 2, divided 2, divided 2. So I will have negative 9 half less than or equals to k less than or equals to 1 half. On the number 9, this should look like in between. Not on the two-way. So that's the difference. Okay, so that's it for our absolute value function. Let me know if you have other questions.